My name is Alex Lawson. I'm a freshman wildlife and fisheries major and soil science minor at WVU. This year, I conducted research in the Davis College under Dr. Brown in the Wildlife Conservation Lab. The objectives for this project were to quantify fragmentation in the Allegheny National Forest and to analyze the source of fragmentation to determine which land use causes the most fragmentation. Habitat fragmentation is a process by which continuous tracts of land are broken up into smaller tracts of land by human activity, such as shown in Figure 1. Figure 1 shows oil and gas related fragmentation near Turnip Run in the Allegheny National Forest, Pennsylvania. We focused on four different types of land use during this project. They are agriculture, residential development, oil and gas activity, and logging activity. We use GIS software, specifically ArcMap 10.7, to quantify fragmentation within the ANF. First, we randomly selected 15 different 1,000-meter sections of 15 different streams within the ANF that included any combination of the four different types of land use that we looked at during this project. We then created a 400-meter buffer around the stream section. A buffer is simply a hollow, digital polygon that surrounds a section of the stream. We then digitize the land within the buffer to classify it by land type. Digitizing is the process of creating polygons within a shapefile, which represent different classes of land use over aerial imagery. We then labeled the polygons using the attribute table for the shapefile and converted the shapefiles into rasters that are compatible with FragStats. Figure 2 shows a shapefile that has been converted into a raster file. Different colors within the raster show different types of land use. In this raster, black represents forested area, green represents oil and gas activity, and purple represents development. FragStats was used to calculate the edge density and area weighted mean shape index of all of the sites as shown in figures 5 and 6. Edge density is the amount of edge that is present per unit of area. This value is expressed as a proportion in meters per hectare. Area weighted mean shape index is a relative measurement of irregularities in the shape of a habitat patch that has been adjusted for area. This allows a direct comparison between values for the different sites. Each shape is assigned a number, with a 1 being a perfectly rectangular or a perfectly regular square shape. The higher the value, the more irregular the shape. After calculating edge density and area weighted mean shape index, we used ArcMap to calculate the percentage of area that is composed of each land use. Microsoft Excel was then used to graph the percentage of each land use by site against the edge density and area weighted mean shape index of the site. After a scatter plot was created, a line of best fit was added to the graph. This allowed us to find the slope of the line, which shows a relationship between land use and the different fragmentation related metrics. The 8 different scatter plots are shown in figures 3 and 4. Figure 3C and 4C both show that oil and gas activity has the greatest influence on edge density and area weighted mean shape index. The best fit line in figure 3C, as shown on the current slide, shows the relationship between the percentage of oil and gas activity and edge density. The slope of this best fit line is 12.453, which shows a much stronger correlation than any of the other land uses. This means that a 1% increase in oil and gas activity causes an edge density increase of 12.453. Similarly, figure 4C, as shown on the current slide, shows the relationship between the percentage of oil and gas activity and area weighted mean shape index. The slope of this best fit line is 0.3026, which shows a much stronger correlation than any of the other land uses. This means that a 1% increase in oil and gas activity causes an increase in the area weighted mean shape index by 0.3026. In future studies, the number of sites that contain each land use should be increased. This will help to ensure the accuracy of the data. This data could be applied in many different fields, including ecology, silviculture, soil science, public health, and many other fields. If you have any questions, feel free to leave them in the comments section below. Thank you.